What's up, team? Today we're finding the areas of triangles. Check the learning target right here. It says I can find the area of any triangle when I have just two side measures and two side lengths and any angle measure. So I have some examples here for us. Some we're just going to run through real quick. Here's a right triangle with side lengths 3, 4, and 5, and here's a little bit of review. To find the area of a triangle, use the formula 1/2 times base times height. Here in a right triangle, you're just going to use the two leg lengths. So it's going to be 1/2 times 3 times 4. Here's the base. Here's the height. If you mix those up, that's okay. You could call this the base and the height. That just rotates the triangle. It's the same thing. So 1/2 times 3 times 4 ends up being 6 units squared. Cool. Here's another one, not a right triangle, but we have the height here. Again, the height is just the distance from, if this were a building, from the floor to the highest point on the roof here. So it's 1/2 times base, which here is 15, times the height, which in this case is 6. And when we calculate that, we learn that the area here is 45 units squared. Notice how we don't even use the 8 or the 11 here. They are relevant to finding the area in a problem like this. You just need the base, and you just need the height. Okay, here's where things get a little tricky. This should be the new stuff. Say you have a triangle that looks like this. Triangle ABC, you have a base here of 9 feet. You have one of the side lengths of 5 feet. You have an angle measure, but you don't have the height. We want to do 1/2 times base times height. So it's 1/2 times 9 times whatever h ends up being. Well, this is going to be a little bit tricky. So, well, at first it is, because we can't do Pythagorean theorem or anything like that because we don't have a right triangle. So what we're doing is we're noticing we artificially created a right triangle here and here. We're going to focus on the small one over here. Triangle BC, you know what, let's name it D. Triangle BCD. And we have an angle measure here at C. We have the hypotenuse of this small right triangle, and we're seeking the opposite leg here. So we are going to use a sine ratio. It's going to be sine of C, which in this case is 49 degrees. And the sine ratio, of course, is opposite over hypotenuse. So the opposite leg in this case is h. The hypotenuse has a length of 5. So I'm going to multiply both sides by 5, and I'm going to switch things around. So it says h equals stuff. It's going to be 5 times the sine of 49 degrees. And, of course, I don't know what that is. So I'm going to grab my calculator, and I'm going to type in 5 times the sine of 49 degrees. And I learn that this height here is 3.77. And we're talking feet. So 3.77 feet. Let's look at our picture, make sure that stuff makes sense to us. I still need the calculator. We have a 9-foot base. We have a 5-foot hypotenuse here for the small triangle. So the height must be smaller than this. It's about 4. Yeah, that makes sense to me. That adds up. Okay, so now we have our height. We need to do 1/2 base times height. That's our area here. Base here is 9. So the area is going to be 1/2 times 9 times 3.77. And throw that in the calculator. 1/2 times 9 times 3.77. We learned that our area for this entire triangle is 16.965, and we're talking feet here, so it's feet squared. There we go. So again, the tricky part with some of this stuff is finding the height, and the height is the distance from the floor to the ceiling, if you're looking at a building. If you had some, I don't know, random distance like this, that wouldn't indicate the height. It needs to create a right angle with one of the sides. And again, we can't call this the height because it's slanted. This is actually longer than the height. So there are going to be times where we need to use trig to find some of the missing pieces. I'm going to do one more example for you. And this next one is going to be a doozy. It's going to take a lot. It's going to look like this, but it turns out it's going to be a little bit more difficult. So stay tuned. Okay, here's our last example. We have two side lengths. So the side length RH of 23 meters, this one down here, SH is 21 meters, and we have a 50-degree angle in here. We don't have the height, and so we need to do some footwork here. We need to figure out where do we want to find the height. There are 3 potential options here. We could look at the height right here, create a right angle from SH to R. We create this little right triangle as well as this big one. And what we have here, I guess we don't really have much here. We don't have any side lengths for this triangle RS. I don't know what to call this here. How about we'll call this point Z. We don't have enough to do any trig here. We just have an angle measure. We don't have any of the 3 sides, so we can't do anything. The big triangle, same thing. We have the hypotenuse, but we don't have this leg down here because 21 is being cut. This whole thing is 21, not HZ. So that height's not going to work for us. We're not able to do anything with that. We don't have enough information. Let's do the same. Let's check this one here. If we were to create that right angle going to its opposite side, we have two small right triangles here. And again, we're not only we're chopping our angle in half, we don't have any of the sides. So this one's not going to work for us. Now, what we are going to do is we're going to take H, go to the opposite side. This one is going to work for us. Again, we have two right triangles that we've created, but the difference now with the choice that we made here is we have an angle measure of this triangle here, we'll call this point Y, SHY, triangle shy. We have an angle measure, we have the length of the hypotenuse, and now if we call this H, because this is one of our heights, we are going to be able to solve this thing. Or we're going to be able to find H. We're then going to have to figure out, find the base here, RS, which is going to be another thing. But let's find this one first. So what we have here, we have an angle measure. We're seeking the opposite side. We have the hypotenuse. We're going to, again, use sine. So it's the sine of 50 equals H over 21. So H is going to equal 21 times the sine of 50 degrees. So what we're going to do here is throw this in the calculator. 21 times the sine of 50. And we learned that H has a height of 16.09. We're talking meters here. Cool. Now we need to find the base. You guys are good. Need to find the base here. And we're going to do this in two different chunks because we'll still call this Y. We'll call this A and B. We're getting overloaded with variables here. But we need to find this piece and this piece, add them together. And then we'll have the base, multiply it by our height, divide by 2, and then we're done with this doozy of a triangle. So this is just going to be a little Pythagorean theorem. No more trig for this problem. So how about triangle SHY first? It's going to be the H, which is 16.09 squared plus B squared equals our hypotenuse squared. So this is going to end up being 21 squared minus 16.09 squared. And we learned that B squared equals 182.2. Oh, geez, this one is turning into a long problem. 182.22. And our B equals 13.498. So I'm going to call that 13.5. That is the distance, or the length of B right here. Let's do the same thing up top. Then we'll add, and then we're done with this thing. Now we have A squared plus H squared, 1609 again, equals 23 squared. Again, 23 squared minus 1609 squared. 23 squared minus 16.09 squared equals. So A squared equals 270.11 times the square root of that business. This is the last challenging piece of this puzzle. We learned that A equals 16.44. Okay, so now we're going to add our A and our B, and that is going to be our base, and we're going to multiply that by our height, which we have over here. So our base, so I'm just going to write out base, is 16.44 plus 13.5, which is what? That's 29.94. Now, the area of this whole thing, this is the last piece of our puzzle. 1/2 base, which is 29.94, times our height, which is 16.09. One more calculation. 1/2 times 29.94 times 16.09, and we learned that the area of our new favorite triangle is 240.87 feet squared. Awesome. We found the area of this triangle. We only had two side lengths. We had one angle measure. We had to use trig. We had to use Pythagorean theorem. This was a mess, but we had the tools to do it. All right, go ahead and check out the practice problems. Let me know if you have any questions.